Hi, this is Chuck Benedict, mentor for Team 997 Spartan Robotics in Corvallis, Oregon. Day after Thanksgiving. Hope everyone had a happy one. I know I sure did. I ate too much. So I'm going to work it off by recording videos. Um, I keep saying last, it's the last video of this TSC color sensor driver series. And I'm recording it only because, in prior ones I'd said that I intended to publish the driver so that other users could just simply include it in their build Gradle and go to town and start using it. I thought that would be simple. Again, I'm not a Java guy, so it's first time for me to do a lot of these things. So I'm kind of learning as I go, and as I learn, I'm recording videos because maybe somebody else finds it helpful. I thought publishing the Maven repository would be the Maven Central repository would be easy. There are other repositories out there for different languages. NPM and Perl's got one, and Ruby's got one, and they're all around. Even C# got into the boat, a year or two ago, and lots of C# stuff out there now too. Seems like with the Maven Central, that's sort of kind of where Java's is. At least that's what everybody seems to be referencing. So I figured I'll be a piece of cake to put my component out there in Maven Central. Yeah, well, I went to the Maven Central site and started reading about all this good stuff. The first thing I realized is that you can't actually just put stuff in the Maven Central site. You got to go to subsites, and then they have this kind of feeding mechanism that feeds Maven Central. All right, well, that's kind of inconvenient, but I was still okay to go through that. Started reading about all of the metadata that I had to create for my project, and then I'm like, okay, so how do I go figure out what sub repository I need to hook up to? And there's some repository hosting locations here, the Apache Software Foundation, and then there's other projects. And I read a couple articles that said there's some other open source software repository hosting projects, because again, this isn't commercial. I don't need all that rigmarole of doing commercial repositories. It's open source. So I said, okay, this looks good. So I went here and started reading about open source. And then, so Sonatype, where did this go? Yeah, right here. Sonatype Nexus Repository Manager, that seems to be the one that you probably use for these types of projects. What do you got to do? You got to create a Jira account. You got to open up a project ticket. You got, some email flying back and forth. Really? Why? Why is this so hard? This is like working with the government. No, thank you. Not doing this. So, well, I said, well, there's got to be a better way. So I started poking around, and yeah, of course there is. Probably some group of developers um, knew about this process and said, this is just total bunk. There's got to be an easier way, and so they created this site called Jetpack, because all I want to do is I have this driver is sitting in our team's repository, GitHub repository, and I just want to be able to yank the driver from the repository, have a jar built that's versioned, and then a consumer like you guys that want to use it, you just put a few lines of code in your build Gradle and away you go. I mean, that's how simple I kind of want this to be. This is what Jetpack IO does. No bureaucratic setting up of this, that, and the other thing. You just tell Jetpack, hey, here's where my repository is. Here's what version. And behind the scenes, once that artifact attempts to be referenced, Jetpack yanks your code down from GitHub into a Docker container running on their site, and it runs the build. Actually, it runs the install task on your build, and it stores off the jar that results and makes it available for download. It's beautiful. It's brilliant. I continue to be amazed by the creativity of what people come up with. And this is they do this free for open source projects. Of course, they have a private repository product, and I'm sure that's how they make their money to support the open source stuff. So it's brilliant. So I thought I would kind of go over how this works in case any of you wanted to do something similar. It's really simple, but just knowing about it, I think is useful. So here we go. First, so again, all these will be in the comments of the video, so you can come back to these pages. I think you can read the documentation here, and it's all good. Some of it was a little, like this string right here, I wasn't maybe 100% sure what to fill in. So I'm going to go to the project and kind of show you what's actually in the project, and I think that'll make things a whole lot clearer. There are some things that you should read on this page, like for example, if you have Java docs in your code, Jetpack will provide a URL to you to access, a public URL to access your Java docs from, which is really sweet. There's also some other features in here too that, if you want to read about it, you can. Let's go to the project. So first of all, this is so I've got two projects to talk about. First one is the actual the consumer project that consumes the device, the color sensor device driver. That's what this is. It's color sensor robot. It was built off the WPI template, VS Code templates. So it's basically a timed robot template. And all it does is it instantiates my color sensor and actually that's about it. It just instantiates it, and that's how I tested it on the roboRio just to make sure that it worked. So the question is, how do you reference the color sensor driver from a basic robot program so that when you build it and you deploy it, it magically pulls the sensor, the driver down and puts it in the jar file and all that stuff. So how do you do that? The way you do it is, so this is the build Gradle file, and this is standard stuff that you get out of the box. You do two things. So you specify, if I can keep from here we go. You specify, there we go, the all projects directive, and you reference two repositories. You reference JCenter, and I'm not even sure what that is. This is, again, off the Jetpack IO site. I just did what they told me. And then you reference a Maven repository, which is actually jetpack.io. Next, in your dependencies, you specify, this is the string that they had documented for you on the Jetpack site. So you specify com GitHub, which is where, we're on the GitHub site, and they do support, Jetpack also supports several other JIT hosting sites if you're on there. So you specify your repository name. So this is our name. You specify, this is our team's name, or the GitHub site name for us. This is the repository name on our site, and then this right here, this is the release version number of the release that I created for the driver. You can also put other things out here. I read on the site that you can put stuff like, I think it's master-snapshot. I'd have to go look at it. And what that'll do is that'll pull the head checked in version on master for you each time. Now, you probably want to do that because that's going to slow your build down, because it's going to have to go out and check to see if you got the latest stuff locally or whatever. But it does have this. It does have that capability. Also note that the compiled configuration that I have here is different than what the documentation says on the Jetpack site. Actually, let me go back over there to show you, because this confused me. So this says to use the implementation configuration, and that's actually technically correct based on the version of Gradle that we're at. Gradle changed configuration. I don't know what you would call this. The configurations that you use to declare dependencies, they used to have a dependency called compile. Now they've split that into implementation and API. And in effect, what that does is if the module that you are trying to set a dependency for has dependencies on of its own, it won't muck up your class path with all of those other dependencies. I think that whole process is described actually because I didn't understand it. It's described in this Stack Overflow article. Again, I'll put the link. You can read about why. The bottom line is that when I put implementation here, like the documentation says, my project wouldn't build because it couldn't find the reference to the device driver, and further, actually, did it build? I don't remember. But for sure, the jar file that resulted, this is actually a fat jar that has all the dependencies required to run your robot program. This is part of what the WPI Gradle plugin does for you, this thing right here. All I know is the color sensor driver didn't wind its way up in this jar file when I used this implementation configuration. So I just put it to compile, and then everything worked fine. I think actually the Gradle or the template project that is created from the VS Code plugin, I notice here that in this fat jar creation directive, it's going against the compile configuration to collect all of the jars that need to go in the fat jar. To make the implementation configuration work, you probably have to do a little change down here to make that all work. I don't want to go into all that. It works the way it is, fine. Maybe the template writer at some point will fix this, and this will have to be changed. But in any case, for now, it works just great. So I also thought that I would show you kind of what it does when you when you put this in, and basically demonstrate for you that indeed it's going up to JITPAC, and it's pulling the dependency, the jar file, down for you. I'm going to clear this. So in case you don't know, with Gradle, when you do a build and your build has dependencies on stuff out on the internet, Gradle will pull the stuff down and it'll put it in a cache. In the users, oh boy, where did I go here? Well, let me go back here. So in the users folder, this is Windows 10, by the way. If you got another Windows, it may be in a different spot because they seem to change it every release. There's a .gradle directory, there's a caches directory, and there's a modules directory. And if I go look in, I think it's files. Yeah, it's files. Notice there's a file here called com.github.team997coders. If I just blast this, I'm going to delete it out the cache. And then I go back over to my project and I do a Gradle build and I do -- refresh dependencies. This is going to force a dependency refresh on this project, which means it's going to go check them all, and it's going to go to the cache, and it's going to try to compare what's in the cache with what's on the outside world, and it's going to try to reconcile them. And if it doesn't find the dependency in the cache, it'll go back out to the outside world and pull it down. And you can see right here, it downloaded from JITPAC the jar and the POM file, which is the sort of the metadata file. Okay, so and of course my project builds, and I've deployed this on the roboRio, and it works great. So I know that on the consumer side, this all works. So what do you have to do on the published project, or in my case the driver? What do you have to do in that project to make JITPAC aware that your project is available to do this? So let's go. Let's close this, and we'll go open up the driver project. Right. So in the build Gradle file of the project, you have to use the Maven plugin, and you'll need to set a version for sure. And you have to have this group specifier right here, actually, is what JITPAC uses to determine where to go in order to get the project. It's got to go to the Team997 Coders repository on on GitHub. Further, you can add, so, my original build before I did any mods for Jetpack, it didn't have this group identifier in it. It didn't have this Maven plugin in it. And it didn't, from here down, it didn't have this stuff. Now, the reason that I added this stuff in, and I think this is also documented on the Jetpack site, the reason I put this stuff in is that this allows the sources and the Java docs to be bundled up in a jar, which will also then be made available on the Jetpack site, which is nice because if you want to debug my code from your project and step into it, you'd need the source in order to do it. And if the source is out there from the repository, it'll drag that down too and make my driver debuggable inside your project. And then this install directive puts a little bit of metadata into the POM file, which is it's the package metadata file. And so it's always a good idea for code that you're going to publish to put a license in it, so that the user knows how they can use it and under what conditions and so forth. In my case, I used some code from an already existing project as part of this driver, and that code was already published under the new public license version 3, so I basically just carried that license forward. This is not a legal video, and I'm not recommending this to anybody. I'm not a lawyer. Do your own research, but it is a good idea if you're going to publish code to others that you indicate some sort of licensing that allows for their use and what those terms of use are. Okay, I think I'm going to end with that. This is longer again than I thought, but hopefully you got some really good info if you want to learn an easy, slick way of publishing your projects to others. Thanks for watching.